So like our sampling or the simulation of our the customer context in recommending getting the recommended products, we are also kind of simulating customer actions, because we don't have customers right now, because this is just a prototype. But when you implement this in a real system, and you will get and when you recommend products, you will get feedback from the customers based on the actions which the customer takes. But right now, since we don't have customers, we're going to simulate customer actions. So this is a function to simulate customer actions. So what are we going to simulate? We're going to simulate two things. One is whether the customer is going to click or whether the customer is going to buy. And customer ignoring the product anyway, it would all those products which are not included in the click and the buy would be ignored. So that is the basis. So let's look at what this function does. So here, first is the click number. So what we're doing is we're just randomly sampling based on some probability distribution. This is some random probability distribution based on assumption that so we are arranging 10 different numbers, 10 different products. We are assuming that the product will not be clicked. That is 0 means product will not be clicked. 1 means one product will be clicked, 2 products will be clicked, etc. till 10 products will be clicked. So that is our assumption. So and we give a probability weight for each of those things. We are saying that 50% of the time no product would be clicked, maybe 35% of the time one product would be clicked, and so on. So we give some weight for these recommended, because and all the 10 products getting clicked would be a rare chance, and that's why we're giving a low probability distribution for that. So these probability distribution are something which you can play around with based on real scenarios. So since we are just simulating and then simulating this, we are just giving this random probability distribution. So based on the random choice based on the probability distribution, we get certain number click number. It could be zero products which is being clicked, or 1 product clicked, or 2 product, whatever it comes as a random choice. Now based on that number, we sample one of those products. We've given 10 top products. Based on this, the customer can even click any of those based on this. So we sample that many products from the list of these products. So this is just a customer actions which we are simulating. Similarly for buy. Now buy is much more rarer choice than click. So we have given 70 weight for no buy, and similarly other distribution. Again, this is something which you can vary, or which you can play around with. And similarly we get based on the number of products bought, we get the buy list. So the output of this function is the list of products which are likely to be clicked, list of products which are not likely, list of products which are clicked, and list of products which are bought by the customers, because we are just simulating these actions in the absence of real customers. So let's implement this. So this is what we get. Now your list could be completely different. So here in the list which I've got these many, this is the list which you got, and the buying list which you got when implementing this. Now what we will do is, now we have generated the customer actions also. Now we will go ahead based on these customer actions. Now we have to update the value functions and the reward functions and all this stuff, which we have seen like similar in post 2 in the K-armed bandit case. So that is what we will do next. So far we have got the customer actions, and then now the next is the most important step in our self-learning process, which is your updating your value functions and your reward functions. So this we have seen in the K-bandit case. So we are implementing the simple averaging method right now. Let's see those functions which we are using to do that. Now the main function is the value updater functions, where your inputs are your segmented products, the products which is being recommended. LOC is like the reward or the feedback which we are giving. So if it's if the customer has bought something, then the location would be 5. If it is just click, it is 1, and if it is ignored, -2. That's what we fixed in the beginning. So this customer list is based on the customer actions which we have got, the list of products which has been bought or either bought or clicked. And state ID is the state ID, and the other dictionaries which we are giving as input. The last one is a flag to remove the products which we have already updated. So this we will see in the when we are implementing these functions. So let's go through the function. So for each product in the customer list, which could be either a click list or the buy list, the first process is to get the reward which is already there, the existing reward which is already there. So we use that function get reward. So the reward, if it's a product is bought, then the reward is obviously based on the 5. 5 is the reward which we get. So we are again using a Gaussian distribution based on that mean value of the reward, which is, say, if it is bought, it is 5, location is 5. If the clicked, LOC is 1, and if it is ignored, then it is -2. So we get a current reward for that customer action. Now once we get the current reward, we're going to update the dictionary with this latest reward, because that's a reward which has been got. So we add the reward function, reward which we've received for the current reward dictionary. The next is to updation of those policies using the mean averaging or simple averaging process. So we use another function called SA policy, wherein the reward, the state ID, the product which for which the customer action is done, and those dictionaries. So let's look into that dictionary now. So the first step is to get the existing value or existing value functions which we get from the policy dictionaries. Against that state ID and the product, we get the value function. Now the next component is to get the number of times this product has been recommended, because that's what we need. Your pull is based on the number of times this product has been recommended. So we get that count that recommend from the number, which is the recommendation count dictionary. We get the number and these things. And then what is the new value? We found that the new estimate is the old estimate plus step value in the reward minus incur value. So we are getting the second part of it, which is your the 1 by n, which is your step size into reward minus the old value. So that is the incremental value which we are returning. So why only incremental value? We'll see in the returning policy. So we get this incremental value, and then what we do is we add it to the policy dictionary, because the policy dictionary already has that existing value, and then we are just adding the incremental value to it. So that becomes your latest value. So that is what is being done. So if the remove flag is there, the next step is to remove flag is there. We remove that product from the segmented product, because that we have already. This will become clear once the whole list is, or the whole process is initiated, which we'll see next. And finally, we are getting into the last bit of our implementation. So we saw that function wherein we update the policy values. Now this line of code, or these lines of codes, are where we call those functions. Now first we look at the buy list. If the length of buy list is greater than 0, that if there is something in the buy list, then we use that function to update those values. So like say for example, your products, the segmented products, all the products which has been recommended is the list, and this is your reward for buy. You give your list of products which has been bought, which came from the customer actions, state IDs, reward dictionary, policy dictionaries, and recommend and count dictionaries. There is one more variable here, or the parameter here, which is the remove flag. So it is for the buy list and the click list. We take the default value, which is true, remove true. So what happens is, once the value updater is run, we all those all those value functions or the dictionaries are updated. And why we have to remove is, once the products has been is bought, now we have a certain set of products which has been recommended. So some have been bought and some have been clicked, and all those that remove function is, or the remove flag is, to remove those products from the buy and the click list, because the what is left behind will have a different reward function, which is -2. So that is why we have that remove flag there. So we first go through the buy list, then the click list, wherein the same process, and then finally we get into the balanced products, which is your ignore list. So here the ignore list, your reward is -2. So that is, and here you don't have to remove that product anyway. So that is why it is defaulted as false. So that ends our whole process. So now what will happen now is, the initial part of the whole process, the learning process would be slow, but slowly, as and when more products are bought and more products, customer takes actions on these, the self-learning mechanism comes in through that simple averaging mean method, and then the distribution of products, or the products which has been bought, kind of aligns to the propensities of buying of different people. Now here everything is dependent on the states which we generate. Now if you want a more personalized approach, that is individual customer wise personalized approach, then we can even increase the number of states into each customer ID could be a state altogether, and then you can bring in more granularity to it, that is based on the customer, based on the month in which that individual customer buys, based on the the day, the time of the day. All this granularity you can bring. Only thing is, the number of state IDs would increase, because the state IDs would increase as a function of the number of customers you have. So if you want to bring in personalization, that's the means of bringing this. So here this is only, so that's the next step which you can try, and you can also try out different of these the k-mean bandit algorithm. Now we have implemented the simple averaging method. You can try the mean averaging method or any other method which for this. Only functions which you need changes is value functions. That is, this value updater will have to be changed based on what kind of method are you going to implement. So which I think it could be a challenge for you to tackle, because that's a simple thing which you can tackle, but just change these value updater based on what kind of methods which you use, and you can see different types of how well these recommendations are. So I would keep it as an exercise for you guys, and then try implementing different variations of this, and then let me know how you fare in this.